This special project aims to study and explore the feasibility of both a new framework for smart road classification and its applicability. The ultimate goal was to establish various smart road levels with the attributes they should have in order to be able to inform user and connected and automated vehicle of the smart road level of the road segment they will be driving on, and thus they could adapt their evolution to this condition. This special project has been developed by a team from Universitat Politécnica de Valencia, Spain, made up by me, Alfredo Garcia, and Javier Camacho, David Llopis, and Jose Montserrat. Finally, we would like to acknowledge PIARC for promoting and funding this special project and for trusting us to develop it. In addition, our thanks to all the members of the project supervision team for their reviews and comments. Recently, road classification system had not only focused on mobility and accessibility, but also on different types of user, as well as various contexts from rural to urban core and functionality. However, none of the classification proposed before 2020 took into account the incipient advent of automated and connected vehicles, which, of course, will require the definition of new criteria to classify our roads. Therefore, a smart road classification should be a system based on automotion level and connectivity, but also on road characteristics and users. The main objective of this special project was to explore the feasibility of a new smart road classification system that could provide information to users and vehicles about the smart road levels, being the base for an efficient road planning of investments on physical and digital infrastructure to improve the performance of automatic driving and the benefits of connectivity. Finally, allow the necessary dynamic management considering diverse variable factors that impact automotion performance. A safer, more sustainable, efficient and comfortable road network is expected. Throughout the project, feedback was obtained from multiple stakeholders through 3 questionnaires. In the last one, a draft of a smart road classification was disseminated and 65 responses were collected. In addition, PR organized a webinar with 162 attendees. One of the main results was that more than 80% consider a smart road classification necessary for the deployment of connected and automated vehicles. In this collaborative way, this was possible to define the benefits and opportunities of having smart road classification, but also the challenge and barriers to finally developing and applying it. Some of them are shown in this slide. The most important benefits and opportunities include the improvement of road safety by providing adequate indication to users, both drivers and connected and automated vehicles. This will result in more efficient planning of investment on physical and digital infrastructure. The new system will facilitate faster integration of connected automated vehicles. Finally, having a smart road classification will mean that the automotive industry will have more information about road performance and can become a clear target for them. The most demanding challenge to address is the lack of coordination between the stakeholders. The necessary legislative framework must include the distribution of responsibilities, but a clear leadership on the part of road authorities should be established. Sharing of experience and best practices can help to minimize the heterogeneity and the different level of adoption among administration and countries. There are too many uncertainties in many factors and relationships which need to be addressed. The social acceptance will be critical, so the simplicity of the system for the end user will be paramount. Much research funding will be needed to define the smart road classification well. Perhaps costs are a constraint for the deployment of the necessary digital infrastructure. An initial smart road classification should be a framework that can evolve and be detailed in the next feature, taking into account the new and improved technology, the research fundings, and the best practices of its application. Many specific objectives have been proposed for a smart road classification. The most important one is safety. A smart road classification should increase the road safety levels, either by presenting an adequate geometric, signage, and pavement conditions that prevent most disengagements of the automotion system, or sharing detailed information with user and connected vehicle on the best automatic driving in each smart road segment at any given time. Other important objectives are a common language to facilitate communication between all stakeholders and being a universal framework through considering different constraints faced by diverse countries. Simple to ensure understanding by users, both driver and automatic vehicle, and so to generate confidence in the user. Finally, a smart road classification should be dynamic to reduce the assigned smart level after sudden variation in environmental and operational factors.
After seeing why a smart road classification system is highly recommended for the deployment of cabs, it is time to explore how we can implement it. First thing to be aware of, there are many aspects that influence the deployment but remain extremely uncertain today, and these will for sure vary in the future. We have grouped these factors into 4 categories. First, the cab levels we have in our roads. A smart road classification system should adapt to all cab levels that coexist at the time. Maybe this implies that the classification system has to slightly vary as newer levels hit the market. Second aspect to control, whether we have a digital infrastructure to share data with our vehicles. There is something expected to come, so the question here is when and for which roads. We have also considered the availability of a smart road classification system as a variable factor. It will let us compare the situation with and without this classification system. And finally, whether we have additional data from automated vehicles, for instance, disengagements or data about the ODD, operational design domains. This information could be used by administrations and operators to better know how their roads are performing, as well as reacting to sudden events. In addition to these variables, we must know that many stakeholders share responsibilities in the traffic environment. We have road administrations, road operators, original equipment manufacturers, which are responsible for manufacturing the vehicles and the driving automation systems, mobile network operators, who are in charge of providing adequate wireless communications to vehicles, users, and so on, users per se, and finally information management providers. In this case, this is a heterogeneous group that includes all other agents that may collect, process, and share information with other stakeholders. Considering all variable factors, we propose 8 different scenarios. 4 of them are proposed for the short term, when only up to level 3 vehicles are available in the market. Scenario A refers to the base condition. In other words, now, in this scenario, there is not a digital infrastructure and no smart classification system is applied. Scenarios B, C, and D provide different situations for which the smart road classification system is always included. With them, we can see how this classification system could contribute to a better and effective deployment of cabs. Another 3 scenarios are proposed for the midterm, in which we also have level 4 vehicles in our roads and a digital infrastructure is available. In this case, scenario E refers to the situation without a smart road classification system, and scenarios F and G are used again to indicate where could a smart road classification system contribute. Finally, in a long-term situation with level 5 vehicles, only one scenario with a smart road classification system is considered. We will see why in the next minutes. We will begin explaining the situation today with connected and autonomous vehicles in our roads, which corresponds to scenario A. Nowadays, users may have some difficulties at determining when to activate or deactivate automation. This may result in too many disengagements on some road segments, or even in safety concerns if the driver is not attentive while the system disengages. Road authorities should therefore get feedback about the impact of cabs on safety and performance. To summarize this scenario, the current situation does not prevent cabs from being deployed. It is very important. However, there are some concerns that are still to be resolved and may somehow limit the deployment speed of cabs. Now we are going to see what happens when we have a smart road classification system. First, in a scenario B with this classification system, the main contribution of this system should be to clearly identify which road segments cannot be driven under automation and which road segments are more prone to it. We have some difficulties here. There is quite a variety of driving automation systems, so only the road segments that clearly lay in one of these groups, either no automation at all or can be driven by many vehicles automatically without many problems, should be indicated to drivers. It is needed that road authorities or other stakeholders invest on determining which geometric and environmental features are behind these disengagements. In scenario C, we add a new feature here, a digital infrastructure. In this case, this infrastructure can collect and share information with vehicles, and this information could be used by users in order to prevent or foresee some disengagements. This constitutes a new kind of a smart level, here indicated in yellow, which establishes that a road segment does not generate too many disengagements and also provides connectivity and information capabilities to vehicles. Finally, scenario D is a desirable situation in which all vehicles are asked to report their disengagements in real time. This would provide massive and very valuable information to speed up the research on cabs, tag the different road segments according to their smart levels, and also respond to incidents in a real time. Now let's see what happens for the midterm. In this case, we have 3 scenarios. Scenario E is the natural evolution of scenario A, in which we don't have a smart road classification system. In this case, again, cabs could perfectly perform along the road network. However, we will have some limitations. In addition to the limitations indicated for scenario A, we will have that level 4 vehicles would suffer from restrictions in the number of zones that can be driven in full automated mode. With a smart road classification system, we have scenario F. In this case, this classification system should add 2 levels. One level for the road segments that present physical and digital properties that allow all level 4 vehicles to perform in an automated way. In addition, there would be, for some road facilities with very good properties, some road facilities that would be of critical interest for authorities and operators. In this case, in order to maximize road capacity and traffic performance, some of them could be close to non-automated vehicles. In this case, the roads should be only open to level 4, level 5 cabs. In this case, this is the blue level, the level indicated in blue. And finally, we have a scenario G that does not include new levels, but the availability of disengagement data. In this case, again, as for scenario D, we have real-time data that could be used for the faster deployment of cabs and also for real-time reaction, real-time adaptation of administrations and operators. In the long term, we only consider scenario H. In this case, a digital infrastructure would exist and explicit data about the operational design domain is expected to be available too. A smart road classification system is considered necessary here, at least to differentiate between the segments that only support cabs and the rest. Summarizing all contributions that a smart road classification system should provide to the deployment of cabs, it seems that the system should present 5 levels. We propose these levels to be named as human way, assisted way, automated way, full automated way, and autonomous way, from worst to best cab support. These levels should be obtained considering 2 types of variables, some of them related to the physical support of the road and some others to the connectivity features. These variables can be summarized or are proposed to be summarized in 2 parameters: the level of service for autonomous driving, LOSAD, and the infrastructure support for automated driving, ISAD, and both of them ranging from A to E. Considering LOSAD and ISAD, the smart level of a road can be determined in a very simple way according to this chart. It can also be rearranged following a diamond shape in the right, in which the bottom represents the lowest support for cabs and the tip represents the highest support. In the special project, some use cases have also been outlined to indicate road administrations and operators how to implement it. This one refers to the scenario B, showing how zones that are not compatible with cabs should be identified and signalized for drivers. Other examples have been provided too, in this case for scenario D, in which disengagement data is used to change the smart road level of a road segment in real time. Now we are going to see some recommendations about actions that could be undertaken now in order to facilitate the deployment of connected and autonomous vehicles and this smart road classification system. We begin with road administration and operators. A priority here would be signing the road segments that present the lowest automation capabilities, in other words, the human way road segments. This would work on reducing driver distraction on automated driving. It means it would work on increasing safety. Secondly, road segments that present very good characteristics for autonomous driving should also be signed as assisted way road segments. In this case, this would work on user acceptance. Drivers would know better when to activate their systems. In both cases, the criteria should be established to define both types of road segments by exploring how the different cabs perform along their roads. This signage should be always advisory. Humans, this is very important, humans are the actual drivers and are the ultimate responsible for the driving task. So drivers must know this, and this is why information and awareness campaigns should be necessary too. Next, one important limitation that has been seen in this project is the very low participation of original equipment manufacturers. However, these have to be engaged in the development of the smart road classification system. Some examples to do so are collaborating with them with OEM platforms or interacting within automotive meetings, forums, standards, and so on. In addition, public information about these engagements coming from actual vehicles would be extremely important to set the thresholds for the different levels that were mentioned before, as well as, of course, to real-time adaptation. There is something that should be encouraged too. Finally, low medium income countries present some particularities that should be considered too. The first one is that they present a much less dense road network and sometimes important disparities too with their standards. There is a necessity to shift from human way to assisted way in many of the road segments, as many road segments as possible, but undertaking no regret options. This would also work, this would also impact human-driven vehicles too, increasing their safety. Finally, when talking about the digital infrastructure, we recommend these countries to focus on 5G coverage, at least on critical corridors. To summarize, we consider a smart road classification system as a necessity that would ensure a faster cab deployment by means of higher user acceptance and information shared across stakeholders. After examining the different scenarios, a 5-level smart road classification system is proposed, and this system ranges from manual driving to exclusive automation support. Finally, some examples have also been included in the project to help administrations and operators in its application.
This special project has demonstrated that a new classification system for roads that are going to become smart is necessary but also feasible and possible. The greatest benefit will be safety by providing all user and connecting automatic vehicle with information on the level of smart road for each segment they travel, which can be variable if limiting factor arise. Additionally, for road administration and operator, it will be a way to recover the leading role in the new playing field with smart road where many other stakeholders have emerged. With a smart road classifications and collaboration agreement will be possible, and the road administration and operator will have a basis for deciding the necessary investments in the adaptation of the physical infrastructure and in the new digital infrastructure. We hope that the result of this special project, as reported in the final project report, will encourage and help them to develop pilot tests and fund research projects which can be shared globally to consolidate a smart road classification model. Thank you.